So we are talking chapter 10, all about hypothesis testing. All right, guys. So this is kind of like the last big topic of the semester. All the other subsequent chapters and lessons will be about different types of confidence intervals and hypothesis testing. All right. So today I get to introduce you guys to hypothesis testing, which is I'm really excited about. So today's lesson, I'm going to kind of teach you guys just the theory of like what or how hypothesis tests work. And then I'm going to teach you guys the first step. All right, just the first step in hypothesis testing. So we're not doing a whole thing like whole hypothesis now. We're going to do that tomorrow. There are 5 steps total. I'm just going to teach you guys the first step today. Okay, so let's jump right in. Okay, skipping to this. So in chapter 9, what we did was we made confidence intervals, right? We took a sample and we made a confidence interval to try to catch the population mean or to catch the population proportion. All right, so that was chapter 9. Chapter 10, right, hypothesis tests, kind of similar in the sense that we are going to take a sample, but what we're going to do with that sample is we're going to test a hypothesis, hence the name. All right, so we're going to test a claim about the population with that sample. And we're going to examine the sample and see, is that sample supporting the claim or going against the claim? All right, so that's the idea of hypothesis testing. All right, so kind of get you guys an idea of how we're going to do that. Okay, so a test of hypotheses is a method that uses sample data to decide between 2 hypotheses, always 2. Okay, and it's basically asking, all right, if I grab a random sample, is that sample like kind of towards the middle, like is it pretty just normal, right? Where I'm not questioning the claim seems reasonable, right? Or do I get a sample that's like really weird, okay? Like a really weird sample like out here in the blue area. That type of sample would make me question a possible claim, right? Because that sample is so improbable. I end up kind of using that to say, this goes against what the claim is. All right, so sample kind of usual or unusual. All right, and that's how we're going to analyze it. All right, so speaking of these hypotheses, number 1, the first hypothesis, there's 2, remember. The first one is called the null hypothesis. The null hypothesis. And this is denoted by H sub 0. H sub 0. Okay. And this null hypothesis is a claim about the population that is initially assumed to be true. All right. It's initially assumed to be true. And that's why we call it the null hypothesis, H sub 0. Now, the second hypothesis is called the alternative hypothesis. The alternative hypothesis. And this is H sub A. It could be lowercase a, it could be capital A, doesn't matter. But this is the alternative hypothesis, and this is the competing claim. Okay. And usually what we're trying to do is we're trying to examine to see if that alternative hypothesis is believable. All right, so we're trying to see if the alternative hypothesis is believable. Okay, so I have a question for you guys. Okay, I have the statement that says the hypothesis, all right, or the hypotheses are always about the population. Okay, so notice when we talk about the null hypothesis, an alternative hypothesis, it should always be about the population. It's never about the sample. So my question to you guys, and I want you to put something in the chat, is why? Why should we be hypothesizing about the population instead of the sample? Or another way I'll ask that question is, why don't we hypothesize about a sample? Why does it not make sense to hypothesize about the sample? Okay, so put your ideas in the chat. Perfect. So yeah, Why am I hypothesizing when you guys are literally, the sample is right in front of me, right? It's like looking out the window and hypothesizing, I think the weather will be good today. And you're like literally looking outside, thinking, I predict the weather will be good today. Like, that's silly, right? Like, why are you hypothesizing about a sample? Your sample is literally right in front of you. You don't need to hypothesize. You have the sample right in front of you. You don't need to guess what percent, right? So that's why we don't hypothesize about a sample. We analyze, we calculate with the sample because it's literally right in front of us. But the population, that we don't know. We don't have the entire, school in front of us. So we need to hypothesize about that. Okay? So good. Nice. Good job, guys. All right, so just remember that when we start constructing these hypotheses, that it's always about the population. Okay? All right. Now, let's get into the mindset of how these hypotheses work and how we decide between one or the other. Okay? So we're going to do kind of a fun example here. Okay, so I'm going to randomly pick people on my random student generator. Okay, so if you get picked on, it is not personal. Okay, this is just a random pick. Okay, so the first person I picked is Jonathan. Okay, so Jonathan, I'm sad to tell you, but Jonathan, you have been murdered. Okay, so we are at Jonathan's. Sorry, I hope you're not offended, Jonathan. I literally picked you randomly. But Jonathan, you were unfortunately murdered, and we are now at a trial for your murder case. Okay, and the suspect, I'm going to randomly pick again. The suspect is Seth. All right, so Seth, you are on trial for Jonathan's murder. Okay? All right, so the null hypothesis, this is what we presume initially. So, Seth, what do we presume about you initially before we even gather evidence? What do we
killed Jonathan?
Say it again?
That I killed Jonathan?
Well, okay, like in America, when somebody's on trial, they're assumed what before evidence is gathered? Do we assume they're innocent?
Oh, they're innocent?
Yeah, we assume they're innocent first, right? So we
Yeah.
Okay, so Seth, we're going to assume you're innocent first, okay? If that's cool with you.
Yeah.
Okay.
Okay.
So, that's our null hypothesis. We assume Seth is innocent. Okay? Which means the alternative, which is the opposite, is Seth is guilty. Okay, so that's our null and that's our alternative. And sorry, I don't know how to do subscripts, but that O and that A should be subscripts on your notes. So, okay, Jonathan, I want you, I want you to think about how Seth might have, because we don't know yet, might have killed you. Okay, but be playful with it. Try not to go too dark. Okay, but if you were to imagine how Seth might have killed you in a kind of funny way, what might have happened?
He hit a home run and the ball hit me in the head.
Oh, was it accidental then, or was it on?
Yeah, it was accidental.
Okay, think of an example where it's more like on purpose.
Okay. He saw me on the street and ran me over.
Oh man, okay. So, all right. That was not playful, but yes, that'll work. Okay. So let's say he ran you over, okay, with a hippopotamus. All right. So let's say that Jonathan, you were unfortunately killed by getting trampled by a hippopotamus. Okay. So you got ran over. Now, question to you guys, and you can put your answer in the chat. It's just a yes no question. Okay. Let's say we are the prosecution and we're gathering evidence for this trial. All right. So we look in Seth's locker. And in Seth's locker, we find a picture of a hippopotamus. Okay. So in the chat, do you think that is enough to convict Seth? Okay. Oh. Okay, good. So most people said no. One person said yes. Okay. I'm gonna go with the no's on this one. And Nick, why would you say no? That's not enough.
Well, like that doesn't really mean anything if you found a hippo in his locker, or like a picture of a hippo.
Yeah, I was like, if you found an actual hippo in his locker, that might be different. But yeah, if you found a picture, why? Why is that not enough to? What?
It's
Why?
just like a picture. It doesn't mean anything.
Yeah,
He
why?
just like hippos.
Yeah. Yeah, he could just like hippos, right? That doesn't mean that he trampled, Jonathan with a hippo just because he has a picture of a hippo. Because, well, why? Well, because a lot of people like hippos, right? That's something that people can have and not trample other people with. Okay, so it's not super unusual, is what we're saying. It's not super unusual to have just like a picture of an animal in your locker. Okay. Okay. So that's not enough. All right. So let's say we keep perusing Seth's locker and then we find a journal. We find a journal, and in this journal, we find that Seth and Jonathan had a heated argument 2 days before the trampling. Do you guys think that is enough evidence to say that Seth is guilty? Yes or no? Yes or no? Okay. 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 All right. Ooh, man. All right. So mostly no. Some more people are saying yes. Okay. Let me see. Jessica, why no? Why not enough for you?
Because that doesn't mean that Jonathan would kill Seth over an argument.
Okay. Good. Yeah. Suspicious? Yes. Is that enough though? Well, no, because it's still probable that, even though they got into an argument, that doesn't necessarily mean, okay, for sure, he used a hippo and trampled him. Okay. All right. Now, what if we went to Seth's house, all right, to gather evidence, and then we found hippo tracks in his backyard? What do you guys think now? In the chat. Enough to convict Seth? Yes or no? We found hippo tracks in his backyard. Okay. So getting still some no's, but more yeses. More yeses. Okay. Avery, why yes in this case? What changed your mind to a yes now?
I think it just kind of adds up. Like all the clues kind of just make sense. Like if they're also, especially because if there's tracks, like you're probably not going to find the actual hippo. So that's probably the closest you're going to get to it.
Yeah. And Avery, like what are the chances that Seth just happens to have hippo tracks in his backyard? What's the
like 0?
Yeah, it's like practical. I don't know about you guys, but I don't have hippo tracks ever in my backyard. So the fact that there are hippo tracks in Seth's backyard, that is super unlikely that he happens to have hippo tracks, he happens to have gone to an argument with Jonathan, and he happens to have a picture of a hippo in his locker. All of that, basically, it's getting like less and less likely that those things just happen by chance and Seth is still innocent, right? So what happened is now we went from the initial Seth, you're innocent. We gathered evidence, and there was enough evidence that made us jump to the alternative that Seth is guilty. Okay? So, yeah, great question in the chat. At what point would you say the turning point goes from innocent to guilty? It's not black and white, unfortunately. That's why the judicial system isn't perfect, because there isn't like a clear cut this. Luckily in stats, there is a clear cut number, but in this example, that it's more of a personal, like, okay, that's too much evidence. I'm switching to guilty. Okay. All right, I want you guys to have this mentality. Thank you, Seth. Thank you, Jonathan, for being on trial. This is the same idea that we're going to have with hypothesis testing, okay? Our evidence is the sample. And when we look at the sample, we're going to look at that sample and say, is that unusual enough for me to jump from the null hypothesis, which I'm initially assuming, is that evidence enough for me to jump to the alternative and take the alternative? Okay, so that is the idea of hypothesis testing. Okay, so some takeaways from this. When we are doing this, we end up with one of two decisions. Okay, so I think I have this on your notes. Yeah, so write this down word for word. This needs to be very precise. Okay, the wording is super precise on this. Your one of two decisions could be you either reject the null hypothesis or we fail to reject the null hypothesis. Okay? We rejected that Seth was innocent because we had enough evidence to reject that. But let's say the only thing we found was the picture of the hippo in his locker. Let's say that was the only thing we found. If that's the case, then we would fail to reject the null hypothesis. That means that picture was not enough evidence to reject the null hypothesis that he was innocent. So that wording is super precise, guys. And even in the judicial system, it's the same precise, intentional wording. Like if you guys have ever seen like the shows, right? Where like the juror stands up and the judge is like, what say you? And the jury stands up and it's like, we find the defendant guilty, right? That's one option. Or we find the defendant not guilty. Notice the wording there. He didn't say, we find the defendant innocent. They never say that, right? Because we don't gather evidence to prove him innocent. We gather evidence and we just either have enough to say he's guilty or we just didn't have enough to say he was guilty, right? So the wording is very precise there. So I want to make sure you guys write those down, okay? Because we're going to use that tomorrow. Okay, let's get into the actual nitty-gritty of what you guys are going to do. So that was a lot of theory. Let's get into the actual specifics of what you guys will need to do, okay? So here is how you write the null and alternative for stats, okay? The null hypothesis. It's always a population characteristic. So you have your choice of either mu for mean or p for proportion. It's going to be one of those two. Is equal to some hypothesized value. Null hypothesis, always, always, always equal sign, always. Hypothesized value will be given by the problem. Okay, now look, alternative hypothesis. Bring those down. Population characteristic, same thing. Hypothesized value, same number. Those will be exactly the same. The only difference with alternative is now just the middle sign. Instead of equal to, it will be either greater than, less than, or not equal to. Okay. Those are your only 3 options for your alternative hypothesis. No greater than or equal to, no less than or equal to, okay? Just greater than, less than, or not equal to. Those are your 3 options. Okay, any questions about that? Okay. And just in case, because in the future I might refer to these, if I call this a one-tailed test, I'm talking about one of these guys just going in one direction, right, either greater than or less than. If I say something like a two-tailed test, this is specifically the not equal to, okay? What do you put for the 2 bullet points? Oh, that was this thing I did over here. That was this. Yeah, so reject the null hypothesis, fail to reject the null hypothesis. Okay. All right, I'm gonna switch. Okay, so now let's get into a problem. Okay, let's see. Cassidy, can you read this one out for us? The prescription drugs.
Sharing prescription drugs with others can be dangerous. A survey of a prospective sample of 592 U.S. teens ages 12 to 17 reported that 118 of those surveyed admitted to having shared a prescription drug with a friend. This is significant evidence that more than 10% of teens have shared prescription medication with friends.
Awesome, thank you. All right, so we're gonna just state the hypothesis, all right? Just doing step 1. So the first thing you wanna ask yourself is, well, what population characteristic am I looking at? Like, am I talking about means or proportion, right? Same thing with confidence intervals, same first step. Are you talking about means or proportion? So in this case, looking at 10%, that's a proportion, all right? So we're talking about proportions here, so we're gonna be using P for our population characteristic when we set up our null and alternative. Okay, the next thing I'm going to look at is what am I trying to show? All right, what am I trying to claim? So it says, is this sufficient evidence that more than 10% of teens have done this? Okay, so here is my big tip for writing hypotheses. My big tip is the first thing you should do is actually write the alternative hypothesis. It is way easier to start with the alternative because this is what we're actually trying to show. All right, so alternative hypothesis, we're asking about proportion, so we're going to use P, and more than 10% is what we're trying to show, so greater than 10%. And that's it. That's your alternative. Okay. And now the reason why I start with that first is because once you have that, the null hypothesis is super easy to do because the null hypothesis is the exact same thing, but with an equal sign. And there it is. All right, that is your null and alternative. Okay, questions? Less than or equal to, that is not an option. Yeah, so if you remember, if I go back a few slides, these are your only 3 options. So that's why it is greater than. Those are your only 3 options. Okay. Less than? Because we're trying to show, is this enough evidence that more than 10% of teens? So the problem, you're actually trying to figure out more than, not less than. Got it? Okay, good. All right, let me show you another one. This one, can you read out for us? Let's go Megan G. Can you read this next one out for us, please?
Yeah, example 2, right?
Yeah. Mm-hmm.
Okay. Compact fluorescent light bulbs are much more energy efficient than regular incandescent light bulbs. EcoBulb brand 60-watt CFL light bulbs state on the packaging average life 8,000 hours. People who purchase this brand will be unhappy if the bulbs last less than 8,000 hours. A sample of these bulbs will be selected and tested.
Awesome. Thank you. Okay, so let's do the same thing. We're going to start with proportion or means. So hopefully you guys notice average life. All right, we're trying to figure out what is the average lifespan of these bulbs. So we're going to talk about means here. And I would start with my alternative. And I know I'm going to use mu since we're talking about average. Okay, so now I'm looking for what am I trying to show? And if I'm reading this, I see I want to show if the bulbs last less than 8,000 hours. All right, so then I'm going to go ahead and say this alternative is mu is less than 8,000, which means my null hypothesis is exactly the same except with the equal sign. All right. And that is it. Okay. Questions before I have you guys try the last one on your own?
So for the null hypothesis, I put mu is equal to 3.
Good. Yes.
And then for the alternative, I said mu is not equal to 3.
Great job. Nice. And Bella, how did you know it was not equal to 3?
Because they don't tell you if it's like less than or greater than. So that was the only option that made sense.
Perfect. Yeah. They didn't specify more than or less than. It just said no longer conformed to mu is equal to 3. So the only other option you had was not equal to. Well done. Well done. Okay. Let me see if there's questions in the chat. Do we have to write the statement that determines if it's a proportion or a mean? No, you do not. You only had to write what I had before. Like, you only need this part. How do we know mean or proportion? Yeah, so you kind of just have to, I guess, read and pay close attention to the problem. I mean, this one, obviously they have the mu there, but even if they didn't, notice the word if the mean diameter is not 3 inches. So that right there tells you it's mean. So it just takes careful reading of the problem to know if it's mean or proportion. Okay. All right. Good job, guys. All right. The last thing I just want us to do is let's go over some careless mistakes that students have done. And I want you guys to see if you can call them out. Okay. So I have some possible careless mistakes that have been made before. And I want to make sure if you guys can tell if these are good or bad hypotheses. Okay, so let's go ahead and start with part A. In the chat, I just want you to type either good or bad. Okay, so try it out. Example A, good or bad. Good. Good job, good job, good job, good job, good job. Good job, good job. All right, so I'm laughing because somebody put BS, and I don't know if that was a typo or or their answer. Either way. Oh, okay. I mean, it's, I guess kind of the right answer. All right, so Nick, I'm going to ask you, why is it bad?
Because it is greater than or equal to for HA.
Good job. Yep, that equal to is no good. It should only be greater than. So good call. Good call. Okay. What about this next one? Good or bad? Good or bad in the chat. Nice, 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 nice. Ooh. Uh-oh. Oh, we got a mix. Oh, we got a mix. Okay. So it's kind of 50-50, I think, the responses. Okay. So, oh, okay, people are switching. People are switching. Okay, good. Good. Okay, Andrea. Andrea, why bad? Why bad?
Because that's a sample mean and you never do it on samples only population.
Yes, good job. This is X bar sample mean. Can't do it. It could only be mu or p. X bar is not an option. Another reason is actually the 4 and the 15 also don't match. So there are two reasons why this was bad. This was bad. Okay. What about this one? C, good or bad? Good or bad? Nice, nice, nice. Nice, nice. Nice. Okay. Ooh, we're getting better. We're getting better at this. Good. This one is good. Yeah, there's nothing wrong with that. You got population proportion, same number, 0.1, 0.1. Null hypothesis is equal to, alternative hypothesis is not equal to. All good. Everything's good. So that is a good one. Okay. What about this one? Good or bad? Good job. Nice, 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 nice. Okay, Tiffany, why is this one bad?
They have different values.
Yeah, so this one, 2.3 and 3.2 were not the same number. I know if you glanced at it really quickly, you might have not caught that, but must be the same number. Okay, and the last one, good or bad? Nice. Oh, you guys are getting really good at this. 100% so far, class. Nice. Nice, nice, nice. Okay. All right. So, Malika, why was this one bad?
Because the null hypothesis always needs an equal sign.
Yes, good. The null hypothesis should always be equal to. The alternative should be the not equal to. So they switched the null and alternative. So this is bad. Good job, guys. Okay. So that is step 1 in hypothesis testing, setting up the null and alternative. Tomorrow, we're actually going to do all the rest of the steps. All right, we're going to do all 5 steps tomorrow. So come ready. You have notes to print and handout also. There's an extra handout for tomorrow's lesson. So make sure you print that out as well, or you can just pull up on your computer and that's fine too.